this is Mr. Spy, and this will be my first video for the Algebra 2 school year of 2020. Unit 1 is on functions. So the first lesson in functions is what is a function. So let's go to the lesson slides and start going through it. Okay, so let's start from the beginning. So Unit 1, functions. Repeat this, Mr. Spy. If you like this video, subscribe to my channel. Hit the like because there'll be 2 to 3 videos every single week covering the previous week's material. So last week's material was what is a function, evaluating a function in domain and range, and that's what the first video is going to be on what is a function. So what is a function? So a function is a special type of relation. A relation is a collection of points or ordered pairs. A function's relation where every point in the value only has one output value. We call the input the domain and the output the range. Domain is usually the x values and the range is usually the y values. So an example of a function would be if you have a list of points 1, 2, another point 3, 4, and that would be a function. This would not be a function. So if I have these 2 points, these 3 points, 1, 2, 1, 3, 1, 4, this would be a function. And the second one, we're not a function. Because for 1, we have multiple output values. Okay? So let's keep on going. So when you had something as a function, look for repeating input values. Another way is a vertical line test. So if you drew a graph, and let's say it was a basic parabola graph, and you drew a vertical line through it, but only hit at one point, that is a function. But if we rotate the parabola 90 degrees clockwise, and now we drew our vertical line through it, it'll hit at 2 points. So it's not a function. Okay? So 1 point, 2 points. Okay. Now here we have a little bit of an interactive way of showing a function. You put $2 into the machine and you get out 1 bottle of Coke. That would be a function. $2, 1 Coke. $4, 2 Cokes. But if I would put in $2 and got out 1 Coke, and then next time I put in $2, I got out 2 Cokes or no Coke, you would know that the machine is not functioning and it'll be not a working machine. Okay, so if you're looking at these 2 graphs, we have graph A and graph B. Graph A is a polynomial function. Graph B is a special polar, 2-dimensional loop function. And you'll notice that group A is a function because it passes the vertical line test. The group B does not, because right there, it hits at 2 points. Some people like calling it the pencil test. Imagine a pencil rolling across your shape. And if while following a shape, it does not backtrack upon itself, it's a function. Same thing here, but here, if you follow, and you go back on the loop, backtracking in the direction you went, and it's no longer a function. Repeat that again. Right here, it's still sort of a function. Once it hits here, it makes this circle or ellipse, and it goes no longer into a function. Here, it's a function, as you could just slide along the graph. Sometimes this test is much harder. It's not all functions always look like functions. Okay, different ways to represent relations or functions. You can represent it as a graph, which we just looked at, a table of values, You could graph it as a machine. This looks like this. Or you'll call it a mapping. Or a set of ordered pairs like 1, 2, 3, 4, negative 5, 6. Or an equation, y equals 2x plus 5. And that's an example of a linear equation. So let's see, which one of these ordered pairs is not a function? So you look for repeated values in the x. 1, 2, 3, 4, and another 4. So there's a repeat, not a function. And I'm going to write FUNC for short for function. Now let's look at number 2. 1, 3, 5, 7, 9. No repeats. Yes, a function. Let's look at 3. 1, 2, 3, 4. No repeats. Yes, a function. So number 1 is the only one that's not a function. Let's look at a different way of telling us something's a function. How about us looking at a mapping? Which one of these two mappings is a function? So you do the same thing, looking for one number that goes to two values. Look at group A. Every number goes to a unique value. Negative 3 goes to 3. Negative 2 goes to negative 6. Negative 1 goes to 0. 0 goes to 15. And 1 goes to negative 1. This is a function. But if you look at B, you'll notice that 1 goes to 15, and at the same time 1 goes to 0. So it's not a function, because 1 goes to two values. It's not a problem that negative 1 and 1 go to the same value. It's a problem that 1 itself has two arrows going to one value. So this is not a function. You can also do this by looking at a table. So here's our two sets of tables. One of these, both of these are functions, because 0 goes to 5, 1 goes to negative 20, 2 goes to 7, 3 goes to 1, 0 goes to 9, 1 goes to 8, 2 goes to 9, 3 goes to 4. And I did both of these as functions on purpose to show you that it doesn't matter if y repeats. It only matters if x repeats. So both functions. But if I would add a new value onto this new graph, let's say I had repeated it and it goes down again to 2, and I'll say 2 goes to 0. And now that I have two 2's in this table, the table no longer is a function, and this will no longer be a function. Okay, my next video will be on function notation and how to evaluate a function. I hope that helps you. And I hope this was useful. This is Mr. Spy signing off. Please subscribe to this channel, and there'll be more videos coming for you on evaluating functions and function notation. Thank you and have a great day.